Servoers, GM. This is Ryan Dennis, head of marketing at OpenServ, and we're back with an all-star lineup for you today. I guess you could call this Shadow Agents episode number 8 or 9, maybe a million, because we've got a very, very special guest today. We're going to talk about why SERV reasoning framework is going to lead to AGI, why AI reasoning fails once they're put into production, and why you can predict that won't happen when you use SERV reasoning framework, and what we've built with the SERV reasoning framework itself to make systems that actually hold up under real world constraints. Shout out to the NEOL team. I want to introduce some incredibly special people and shoot some rapid fire community questions at them. First up, we have the CTO of OpenServ, Armagan Amcalar. How you doing, Arman?
I'm very good. Thank you, Ryan. How are you?
This is the best day ever. I get to chat with you again. My brain gets larger every time we speak and in public. People can see the size increasing rapidly. And next, I've got Dr. Eyup Cinar, our AI research partner, former ex-NVIDIA researcher. Eyup works at the intersection of academic rigor and applied systems. Dr. Eyup, how are you doing? Welcome to the show.
I'm doing pretty well. Thank you. Happy to be here. Excited to discuss our new work and give some insights into it. Thank you. Thanks for reminding me.
Listen, this is really special. I want to shout out everybody in the OpenServ community. They are extremely excited to have you both on today. So let's give an origin story right here, right? You guys both wrote a research paper published by Cornell University's archive. Please tell us how you came to know each other in the first place and what your relationship background is like.
Eyup, would you like to take that one?
Yeah, sure. I am associate professor. I have a PhD from Rochester Institute of Technology in the US, and post my PhD, I've worked in academia like 5 years. Then I got back to academia, and I've been, providing consultancy, like technical partnership to startup companies or mid-size companies in the industry in my academic line of work. Actually, one of the co-workers of Arman was my student. He mentioned that Arman is working on some nice research topic and wanted to have some academic direction into the work. And I said, okay, let's meet and discuss what we can do, how we can take the level of the research to the next level. That's how we actually got introduced to Arman.
Arman, can you corroborate this story? What was the first time you met up with Dr. Eyup and started to realize what could happen here?
So yeah, the idea was like we had this prototype that showed some great results, and I was like, I'm pretty sure this is going to be something really big, like because the results that we're seeing are mind-boggling. But it's very much limited to one prototype, one use case. It's very difficult to generalize it or show how it applies to the rest of the industry or how it goes head to head with other approaches and so on. So I was like, okay, let's turn this into a little bit more academic work, and let's make sure we cover all the grounds and come up with an indisputable work to show to the world that what we're working on as a methodology is a great approach for anyone else to adopt. And I was looking for academic partners, and the beauty of that is we have a very large network of individuals, best in class team members who had amazing teachers. So it was very fortunate that a colleague of ours had this, hey, like we have this professor who's crazy good in AI and like has a rich history in research and like his next level international researcher. Like, wow, okay, that's very impressive as a background. I would definitely love to meet, so let's get together and start working on it. But then what Eyup didn't tell you is he ghosted me for like 6 months. It was like, I'm not sure if this idea will work. I'm not really sold on to the idea. So let's try it in more situations and so on. I was like, please, can you try this yourself? It's gonna prove itself. And then I think it was a hit.
Yeah, being a part of the a researcher, a scientist is becoming skeptical to everything that you read, to everything that you learn. That's how you tackle the big problems, right? So I guess it's part of my job. So
Yeah.
That makes sense. Some of the best relationships start with someone playing hard to get, but it is true when I speak to analysts and people not of your caliber exactly, but when folks who study and give third party validation to some of the best AI tools, even they are kind of hard to convince on how this is too good to be true when they look at some of the data that we've seen. So, what was the first realization that you had, Dr. Ayup, that SERV reasoning framework was special, and what exactly was that sort of light bulb moment that convinced you?
right. So what we did as a first part of the collaboration, I said to Arman, we have to ground this work to the prior work of the literature. So that's how you produce a scientific work. You have to ground it to the state of the art. What has been done before. Or has anybody done this before? So you have to dig into the scientific literature work and digest the materials and see if somebody else has really did something similar to this. That's what we call the background work, literature work. So we did an extensive background and literature work, try to understand what let's say Google has done before, the other big AI companies has done before, and they try to tackle this reasoning problem before, and they did things that stupid, but they published it very well. We observed, and after that, I said to Arman, yes, like there's a research gap where we can linked our research work to the prior literature work, and tell the scientific community we have beat the state of the art. So that's the first step I ever done. Actually, it was another white paper that we published on OpenServ website, pretty much criticizing all the reasoning, LLM reasoning work, what people have done within past 5 years, which is a huge amount of time frame for generative AI. And we've seen that there is a really important critical gap here that we can fill with this work. So that was the aha moment that I said to Arman, okay, bring me the results. Let's talk about it.
And that leads us to sort of the theme of this show, and we'll work in some incredible community questions after our Telegram AMA yesterday. Shout out to PT and Freud and Rimtapak and everyone else. I guess the high level question is, why is ROI in AI, especially for enterprises, Fortune 500 companies, why is the marketing 5 years ahead of the results? Why is it not really paying off the dividends? Why does AI reasoning fail in production?
Should I get that question,
Go
Arman?
ahead. Go ahead.
I guess one of the thoughts I have, and I also have read some industry reports on that. About 80% of the AI projects, when it switches to the production, fails. The reason being is that it starts with a really nice scientific project. People get like POC is really nice. Everything is just so beautiful, but when you put it into the production, it just like blows, because the real world data and the real world performance of the model, it doesn't match the BKMs of the companies. And one of the surveys was saying that within 2025, approximately $64 million actually lost by the companies who tried to initiate the AI project and failed.
Wow.
So and CEOs become a little skeptical on this because they don't. The initial part of the project, the POC, doesn't care the production and the economics of the model. So, like putting the best state-of-the-art model in production doesn't always solve all the problems. You have to be a production-oriented and think about it, real-world problems a little better. I think that's what lacks currently the current state-of-the-art AI and the production AI systems. There's a huge gap.
And that skepticism from CEOs and leaders is something we hear constantly. And I want to slow this down for a second because what you just said lines up exactly with a question that came directly from the community. And I'll point this to Arman. Why does AI look so good in demos, but
Right.
it doesn't really hold up when you try to run it yourself or when you see it on in a
Right.
company's platform?
Here's a little fun story that I'm going to tell you. This is usually talked about in QA, quality assurance circles. So you design a bar, and then you have a quality assurance person checking it out, right? They go to the bar, they ask for 1 beer, 2 beers, 3 beers, half a pint, just one shot, and they ask for different drinks. They ask for seats and tables, and that's great. And you prepare for all of those things. And the first customer walks in and they ask for the toilet. And that's basically the reality that we're facing. The real customers that are using these products don't behave the way you think they will. And in demos, everything is constrained. It's basically like doing an experiment in the lab. Every single bit is designed to give you the right results. So you're changing the way you prompt these models. You know how they work good and so on. And you design a very brittle system because it's very difficult to get results from AI. As soon as you get a result, you're like, okay, we're done. We can publish this. And then the reality hits really hard. And what you see is people don't know how to prompt it, how to talk to it, how to use it. And they use it in the wrong order. In the like maybe they go to the toilet and try to order a beer from the toilet itself. It's basically like the level of knowledge in the people is also not there, so the adoption doesn't pick up. And then obviously the AI systems that you design under lab conditions don't meet real life because they don't know how to reason and work around the request from the user and how to solve that request. So it just falls apart. That's the biggest gap. And one more problem is repeatability. Like if under lab conditions you do 10 tests and 9 of them are successful, in production you have hundreds of thousands of tests. And the I guess we're going to talk about that later a bit, but like the error rate is compounding. So what you saw is like 90% success becomes like 30% success when you hit the market. And that is one of the biggest issues, reliability and predictability or repeatability of the results. And LLMs are really notorious in giving you these 3 things.
And we got this question in the chat. Thank you so much. This is from Mert Y3P7Y. Are the AI startups that fail mostly AI wrappers, or are they companies that actually build AI models? Most of them seem like wrappers. So I guess to differentiate, Dr. Eyup, what you were mentioning was when larger, maybe more production-ready companies are switching to AI systems, 80% of them fail. But this question is more about startups. So can we key in on here to those small teams, those single founders? Is AI failing them when they're building things, or how do those newer nascent models work?
I guess to pinpoint the actual answer to that question, we have to talk about why these models actually can become catastrophic when they give like bad results, what we call the hallucinations. This is now actually a huge problem for the industry, and it's really hard to disable it. Although, like many APIs, like let's say you use it from OpenAI, you have a switch. You set it to 0. I don't want it to hallucinate. that doesn't guarantee the hallucinations. Actually, I'll give you one actual example of it was, I think, last year, Air Canada. They put a chatbot into their systems, and they used the state-of-the-art model. Then one customer, they chatted with the system, and what the customer asked was a refund due to the loss of his mother. And the chatbot said, okay, yeah, you can get a refund. There is something called the bereavement refund. You qualify for it. And then the customer was happy because he can get the money back. Then Air Canada said, no, you cannot get this money back. So the customer sued the company. And the Canadian court decided that you are liable for your chatbot's responses. So it is your liability to cover the refund. So all of a sudden, one chatbot become the liability of the Air Canada.
Right.
I'm pretty sure the engineers that put the chatbot over there used the best model in class, but they couldn't make they didn't use the right technique to disable the hallucination. So I don't know if this really answers the question of it is both the models and the wrappers actually that result in these catastrophic problems. And when it is in a business that is so deterministic, let's say a financial sector or bank sector, there's no room for error. So you have to be really, really smart on top of what the OpenAI or Google provides to you as a model, right? So the guardrails are really important, and reducing the hallucinations or generating or coming up with the techniques that reduces these hallucinations are really, really important.
Well, that example is very sobering. I
It
mean,
was actually bubbles. I was laughing when I was reading it.
wow. Okay. So let's switch gears to the money side of it, right? I think there's an emotional side, and I think you touched on the financial impact that these fails can have when hallucinations go wrong, when reasoning goes unbounded. And the SERV reasoning framework is a world changing environment for artificial intelligence, machine learning technologies that I think people will only come to understand in the next few months and years. But let's talk about the gains that are to be made and that are being missed out on. With this question from the community, what does the 122x performance per dollar improvement actually look like in real production workloads, according to your research?
So the gain is there and it's huge. And basically what we set out forth in the paper is Braid, the approach that we came up with is so malleable that you can either use it for economic gains or you can either use it for accuracy gains. And we have some projects where we were able to simplify the model and use a lower tier model. So we just can use a nano tier model instead of a top tier model, and that gives you huge benefits in latency and in the AI spend that you're doing to get the same level of results. This is for example, a use case in Neo. When you're doing a search, we try to understand what kind of personas you're looking for, what kind of tenets you're looking for in a network of people. And the way to do that is to enrich your search with different keywords. And on the cover, it looks like a very simple task, right? Like look at the user's request and come up with matching keywords that we can use to expand our search. But A, it doesn't work. B, because the user's input might vary wildly. And B, it's not repetitive or repeatable, the same query ran multiple times generates vastly different results, but it shouldn't in real life. And the output is using a top tier model just doesn't solve this, doesn't make it better. And what we can do with Braid, for example, with the SERV reasoning framework is we can take this down, put it in a bounded reasoning approach, and make the nano models achieve repeatable results, which gives you performance per dollar improvements. But I also have to say, after we introduced this to the industry, maybe that's because of the use cases that we had in our partnerships with governments and enterprises, most of them opted for better accuracy most of the time, because that's what's really pissing people off. Like the top tier models are not enough in their reasoning, in their clarity, in their repeatable, reliable results. So the majority of the use cases we have are for, okay, yeah, if it's 20% improvement in accuracy, I'm definitely going to take it from 75% to 95%. And because that matters way more in a production system if you have the budget for it. And for simpler tasks that should be repetitive, it allows us to use lower tier models because accuracy is not a big concern as much as reliability or repeatability there. So those are two different ends of the spectrum.
Dr. Eyup, in a few words, could you share what kind of requirements allow enterprises, government tier partners like NEOL to adopt the SERV reasoning framework?
For the one of the aspects is the what we call this golden quadrant, and I really like that term. So let's think about two ends of the swing. The one end is the ultimate accuracy. The other one is the ultimate money that you burn with the model, right? Top OpenAI model. So where do you want to put yourself or align yourself? If the accuracy is really important, so this research allows us like a lookup table of an engineer can look this technique and say that if I want to boost up my accuracy, I have to go through this path or have to stay in this quadrant. Or if, let's say, the accuracy is not an issue, but the money is an issue, I have to go to the other end of the swing, right? I think there is no paper that gives this perspective in the literature. And I really like that technique because of this particular reason. What we call the token economics. It gives the full perspective of how or where you should position yourself. If you have too much money, like a government, let's say, you can go for the top accuracy, no problem, right? And if you don't have too much money and you can risk a little bit of the accuracy, then you can optimize where you should position yourself. So this research gives you that direction for what we call the SERV reasoning. That perspective is, I think, really important for the industry. And that we could not see that in other literature work that we scan through and digest it. We talk about that also in the paper.
And one thing that I can add to this is, again, repeatability. Like when you work with a government, they only want the best results. And they want those results all the time. And like there's no excuse for, oh, well, the AI didn't give you the right response this time. It's just not acceptable because, like, I don't want to say human lives depend on this because, like, it's not obviously in deciding on human lives, but the use cases that we've been working on require precise clinical accuracy because that's what a human would do. Like if you had hundreds of researchers working on a topic, searching through your network for the right people, for example, they apply a very critical mindset and always come up with the best results. If they know how to do that, the government just expects it to be done with AI in a much more broader scale, and it has to be right all the time. And that requirement is something you just don't get with the foundational models, like off-the-shelf models. It's just impossible.
So I think what we need to be steeped in reality about here, especially, I mean, for everybody in the audience, we all see incredible tools, Claude Code and Nano Banana, and there's fancy fandangled things. AI is going to bring out so many cool cultural moments and touch points, but in a realistic situation, the infrastructure that we depend on, that our lives depend on, is we want predictable AI, maybe more than smarter AI or cooler AI. And that points to some of the most successful companies in the world, right? I mean, you look at McDonald's, Coca-Cola, even Nike. Maybe they have some factories that are really, really well maintained, and maybe some others are using child labor or doing some not so great things in those factories. But the end product, for some reason, is very predictable. You go to a McDonald's in Dubai or Brooklyn, New York, it's the same Big Mac, right? So I think we should be thinking about that for AI. Why is it that when you ask a question 3 times, you get 3 different answers, and maybe 2 of the 3 have hallucinations in them? So let's make that tangible with another question from the community. Can we talk about, in general, like, where is the SERV reasoning framework materially improving outcomes predictably? Is it because of the SERV bounded reasoning? Is it the fact that is the way that the framework is actually set up itself? Is it something else that we're missing? What is it that works in these environments so well and so profitably?
I think it's definitely the boundary reasoning part, because some community members had great charts that we also posted on X, right? Unstructured thinking is what the top tier models do right now, and you can never guarantee that it's going to think the same way. And it's open-ended. You don't know when it's going to end and what paths it take. It's not coded. And with bounded reasoning, we have pretty much a template, a blueprint of how you achieve the outcome. So it's a process of how you should think about this, and not open-ended. And I think that brings that level of repeatability that the enterprise is looking for.
Yeah, Dr. Eyup.
Yeah, maybe I can add on to that a little bit of the theoretical, as far as I can simplify it, knowledge. The way that the technique works is, so the LLMs are black boxes. There is a prompt that enters, and then another word is generated. So what a recent study has done, it pretty much did a brain surgery on one of the famous Meta Llama models. So what they found out, the researchers, is that within that black box, there are 2 sections. The first section, where 16 layers, like the first layers of the neural network, the model, it only relies on a pre-trained data. So this world internet data that it collected within the model to come up with the answers out of this black box. The other half relied on what you put in the prompt. Like we call it in context learning, in context priors. So there is a huge room for improvement for no model what this can be an OpenAI proprietary model or any open source model. The stuff that you put in that prompt or in context can really boost up a lot of the things or the results. So you have to be really smart in the second half of the model. And the study suggests the second half of the model looks at what you put as a, let's say, examples for that problem. Or if you give a really sophisticated and well-structured examples or the blueprints, we call it the few shot exemplars, it makes actually a reasoning quite a lot better. So by simply wiring the prompt really well in a sophisticated manner, you can really boost up the accuracy of the model. So this is actually proved in the literature. A lot of the work that we see in the literature rely on this. Some of them, they treat the problem as a search problem. They iteratively, try to generate some examples of that blueprint so that the model, doesn't get lost. What we make here with the SERV reasoning is a really sophisticated way to direct the model in the second half of the layers really well, so that the model doesn't get lost. Think about it as like you're climbing a hill in a really foggy weather. You have to find your way up to the hill by just looking at the breadcrumbs, right? So the more signal you give to the model, the better way or easier way you can find the top of the hill your way. If the model cannot find its way in that hill, it starts hallucinating. It has to give you an answer, right?
Mm-hmm.
So the important part here is to develop the technique, a sophisticated technique like SERV reasoning, to make this in context engineering a really sophisticated, so that the model doesn't get lost.
So today's large models are they're free-form thinkers, right? Because they're trained on all of this data from all of these different disciplines, all the Google searches, and SERV turns that into a step-by-step recipe. So you can get the same high-quality answer every time instead of random ones by following this like bounded area of expertise that you want them to focus on. So if I'm an engineer and I'm thinking about, how do I know? I'm an engineer at an enterprise company, right? How do I know where I am on the golden quadrant? How do I know how great or how poor the AI systems that I'm using now are? And how do I compare that to what SERV might do differently?
So I think there are some baselines, like what we call zero shot prompting. Like you give a prompt to the model and you look at the result. You don't give any directions, you don't give any examples, and it's your baseline. It totally relies on the pre-trained this world knowledge and gives you an answer, right? So if the problem or the question that you ask exists in the model, it will give you the right answer. But for really complicated problems, complex math or some agentic problems in production, simply giving one line of a prompt doesn't solve your problem, or it can direct you straight to the hallucinations. So if your solution is way better to this zero shot example or to the baseline, you're game, right? Another level is what we call in the literature the chain of thought reasoning. It's a standard one. People are trying to initiate the thinking of step by step, like trigger the activity in the model towards the model, make more searches within itself, so that maybe it can solve the problem if there is no prior information of that world information embedded into the weights of the model. So chain of thought reasoning is another baseline. And on top of that, now sits what we have, the structured reasoning, with the SERV reasoning, right? So if your result is way better than these two standard baselines, I just give an example, you should go for it. I'm pretty sure it will do way better than the most of the expensive models.
And when you're talking about doing way better, we're also talking about doing better financially, right? We have some questions about performance per dollar. I want everybody to put on their calendar performance per dollar for every month. What was your performance per dollar this month? Maybe I spent too much on takeout. personally, but from an AI standpoint, what is performance per dollar? If you could give us a quick definition. I know it's all over the paper, but we have this question from Room to Pack, one of our
Right.
community leaders and an incredible human being. What are the limits of performance per dollar? What lies beyond? How much money can be made, saved? What does PPD do?
So right now, the definition of performance per dollar is with $1, how much reasoning, how much accuracy can you get by using different models? And the baseline is GPT-5 in the paper. So we're saying like whatever performance GPT-5 gives you is the default. It's like one performance per $1. And then by using different techniques, shorter prompts, longer prompts, braid or not, or different models, you can basically change the game, the economic game, because the nano models are, for example, 25 times cheaper. So if the nano models are like spending the same amount of tokens, they already give you 25x PPD. If they give you the same accuracy, but of course they by default they don't give you the same accuracy, so it's much less, it's unusable. But by using SERV reasoning, what you can do is you can get better results from a nano model for less tokens in the prompt and less tokens in the output. Basically, then you multiply these three, and that gives you the performance per dollar. Like by default, it's, let's say it's the same accuracy, all right? It's 25 times cheaper. If you're just 10% better, that's already 27 times, 7.5 times better performance per dollar. And then if you increase, if you're able to decrease the number of input tokens, your prompt, by a third, then you get like 75x. If you decrease the number of output tokens by a third, then you get 200x. So what are the limits? They depend on the cost of these models. On the paper, we didn't try with cheaper models. Maybe, DeepSeek R1 is way cheaper. There are other cheaper models out there. Maybe the absolute limit is maybe 1,000x. We don't know. And that's for future studies or for the industry to find out. But on the paper, we looked at the OpenAI GPT series, and therefore, I mean, there is maybe a hard boundary. I saw some results in our benchmarking about like 150x, 200x that were not easily repeatable. But that's mainly because the economic difference in between these model tiers is 25x to start with. But if you are able to apply this to a cheaper model or a more application-specific model, then you're able to get these costs down. So you can increase the PPD by, I don't know, several orders of magnitude. And what I mean by that is if you have a specialized model that's very, very tiny, only good at doing certain bits, and if you can get braid to work there or the SERV reasoning to work there on that model, then obviously this jumps to several thousands. And that's basically what we are trying to tackle right now, what we're working on. How can we come up with a custom model that's way better at reasoning, not necessarily very good at knowledge, because you have the larger models for the knowledge bit. But what if we come up with a model that's crazy in decisions? Because this is the definition of the game, right? Like braid, that's D at the end is for decisions. This is for AI to do decisions and decision making. And if you can come up with a model that is great at decision making, great at following these braid charts, or great at coming up with these, then you basically again change the entire economic landscape. And that's basically what we're after. And that's our belief that in the future we're going to have multi-tier setups of these models for all of these agents. Like you need one agent that knows everything You need another agent that is amazing at reasoning, and maybe another one at tool calling to do external integrations. But yeah, this is where we're headed with a custom model as well, because we believe we could have like way more economic advantage by doing that.
So the real unlock is separating knowledge, which obviously LLMs have a ton of, from decision making. We're, I guess machine learning, AI, as we apply it, as we apply that science to our daily lives, it's really all about the decisions they make, how they
Right.
decide to word things, how they decide to draw things, and that's what we talk about all day. But building tiny, cheap models that are insanely good at decisions might be better than building a huge, genius, knowledgeable system that can hallucinate and go wild, take you off track. So if you actually crack that decision specialist model, what changes first for enterprises in practice? And I want to, if we could share a little bit about Neol, because I don't think our audience fully knows or has celebrated with us this new partnership that we had with Neol, where we have this foundational design partnership where we are working with Neol to apply SERV reasoning framework in high stakes environments. And Neol, if anybody doesn't know, is an AI powered network intelligence program and platform that's used by enterprises, public sector institutions, even the United Arab Emirates, to understand, evaluate, and mobilize complex networks of people, programs, and partners. So we're inviting
Right.
everyone to check out the work we're doing with Neol through an upcoming case study. And we've got a landing page where you can, enter your email if you're excited to learn more. But just tell me a little bit about what we've learned so far. If you can give me a peek under the hood about what you've seen improve with Neol, and what people might take from this for their own lives or projects.
So it's all about decisions. That network intelligence has a lot of real intelligence baked in, real decisions about how to evaluate people's CVs. Like that's the simplest I can put it. You have hundreds of different categories of evaluation, and you need to know how a person applies to those categories. And that's a very difficult decision, because you have hundreds of branches. Like you could take all different cases. And one reason we wanted to use AI here was also because we wanted to eliminate bias and increase diversity, because a human might be biased towards a specific school or a specific company that person worked at or whatever. And with AI, if you can make this repeatable and reliable, then you get immense performance out of this. And that's basically the nature of our work. And when we first started with, or when Neol started with the state-of-the-art models, again, it was all over the place. This is called explainability in the world of AI, and Dr. Eyup would describe it way better than I could. But there is no understanding or reason for why AI decides a certain way. Like, why did the LLM give me this output? No one knows. The LLM also does not know why it did so. Even if you ask, it comes up with a retrofitted explanation, but it's not the true reason for why it came up with that answer. So what we have there is, we need a repeatable, machine readable blueprint that AI can follow, so you actually can know where it branched off, where it started hallucinating, what it did wrong. So you also bring explainability into these workflows, which is crucial for government systems. If anyone worked with insurance companies in the US, or credit companies, loans, banks, like you often get a result from that company, and you ask, like, why did this happen? Why am I treated as a fraud? And they cannot give you an answer. They just say, like, the system just decided there's fraudulent activity in your cards, credit cards. Like, why? I didn't do anything weird. And a human evaluates it and there's nothing wrong, but they cannot override the system, and it becomes a huge problem. So we also want to solve that challenge. And that was basically like the very, very first challenge. We need explainable AI. We need a repeatable workflow so that we can get accurate answers, and we know, like, with high accuracy, that we're going to get those answers. Of course, nothing can be 100%, because this is not a deterministic system, and like we cannot sell anyone a dream. That's that's impossible literally in the world. No one can give you 100% accuracy. But the question is, how many nines will we have at the end of 99 to get closer to 100%?
Okay. Well, it's time for a rapid fire based on who's been paying attention during this conversation. And I got some one line answers only for you, gentlemen. I'm going to start with you, Dr. Eyup. Are you ready? You guys ready for this round? Okay.
Good.
Sure.
One sentence. What does predictable AI mean?
Predictable AI means something that you can control the answers.
Beautiful. You want to sneak in a second one there? I'll let you cheat. You're a guest.
Given an input, you should know what the output should be. Just by looking at the input, you as a human should know what the output should be. It shouldn't be a surprise. That's basically what it is. And most of the time, it's a surprise.
Or to put it another way, it's an AI that you can put some guardrails.
AI you can trust, says J.CRV. Not bad. Not a bad one.
Right.
Dr. Eyup, give me one rule of thumb for new founders wanting to integrate AI today. One rule for them to follow.
Don't get hyped up with the POC, and make sure that you assess all the risks based on the industry that you operate, and cover all of the aspects of what can go wrong. And if all of these costs is smaller than putting in human labor, then go for it.
Terrific. Armand, your turn. One sentence. What's the fastest way to tell if an AI system is weak, brittle, poor decision making?
If it's using out-of-the-box models, it's brittle. I haven't seen any AI system that uses the OpenAI, Gemini, DeepSeek, whatever models.
Call them out.
It's just not good. There's it's all an illusion, hallucination. They break really fast, really rapidly. So that's it.
Nice.
And of course, you can increase this. If you have a multi-agent system, you now double the error rate. It's actually a square function because they multiply the errors of one another. If you have two agents, it's like error to the power of 2. And if you have 3 agents, you have more errors. And it's really a brittle system. It's way, way, way difficult than most people think to build a multi-agent system, let alone a multi-agent autonomous orchestration platform. Shameless plug. OpenServ platform is the killer, is the leader in this race compared to OpenAI or Google Opal.
Question from the community, Dr. Eyup. You can give me just a couple sentences, couple thoughts here. What new insights do you think are emerging at large around the signal to noise ratio between human and machine interaction in 2026?
I guess the direction of the research that goes through this increase of signal to noise ratio is that adding as much as modality as possible. Modality I mean that right now we rely on text data, right? There are many forms of data in the real world that you can fuse to enhance that signal. For example, we do not operate as humans in a textual world. We operate in a 3D world. So we have our eyes are image sensors of data that we can process daily to make some inference, some reasoning, right? So the multimodality is a huge trend that these models can, the better that they digest, the better that they become in terms of the signal to noise ratio. Because most of the problems in real world is not represented by only text. Even the cognitive reasoning of humans, right? We don't think and reason in natural language. We have a meta level of cognitive reasoning abilities. So we somehow able to embed these strategies into the new models. And only relying just text and next token prediction with LLMs will be limited.
Terrific. Well, I have some questions about how AI will take over the world, and I'm going to give you guys some really hard hypotheticals. But before that, I want to do some quick house cleaning and housekeeping, I should say. It's been a while since we've had one of these spaces, so I want to get everybody here wrapped up into what's happening. Please follow us on X at OpenServ AI to stay tuned, because we're literally doing academic research, applying this to real enterprise and government level systems, as well as helping individual founders and builders like you to create your dream. We're helping explorers trying to figure out what they want to do, what they want to build, to do that just from their computer. You don't need to be a billionaire to have access to the best tools in the world anymore. We've changed that paradigm. So these two gentlemen you see in front of you here, they built this incredible research and then paper on SERV reasoning framework, also known as BRAID, that cleared a lot of technical checks and is now in peer review at the Artificial Intelligence Review. So round of applause for you two on that, because the numbers are crazy. We mentioned that 122x better performance per dollar compared to GPT models. We saw an 88% reduction in hallucination rates. These are crazy numbers for Fortune 500 and government scale operations, because even a 1% difference in revenue or profitability completely changes their quarter and their year. So congratulations on that again. I also want to give a shout out to everybody who's been paying attention to the SERV Launchpad. This is where autonomous startups are going live. The first launch is by Ari, okay, who launched Better, also known as @TradeBetter app. I wanted to really congratulate that first tokenization platform launch. It's incredible to see what can be done with AI and Web3 combined. Again, we're the only ones building this kind of system that also attaches AI to Web3 in this way. So went live on January 21st, was incredible. We've got Oasis and we've got a couple of others in the queue. So stay tuned on that. Also, if you want to have AI working on your behalf and running for your startup, do not be shy. Reach out to us, because we have been building and testing, and I've been cloning myself to build a marketing department that is better than me, because it doesn't sleep, doesn't eat. Okay, more productive, I should say, to help you with branding, video graphics, marketing, growth, social media management, all that kind of stuff. You'll have a full AI team with SERV Run for hiring, sales, community growth, partnerships, operations, anything you can think of. So every solo founder can have a 10x level team. And so we're working on all this today. So thank you. Want to give a huge shout out to the community for staying tuned and keeping up with all these crazy developments. I can't believe that we're still in January. It feels like we've done 6 months of work since New Year's Day. So yeah, thank you so much. Okay. So, gentlemen, I got a crazy question for you. Is SERV reasoning framework, right, this bounded reasoning that allows even a really not that knowledgeable, small, cheap LLM or AI model, if it can make incredibly good bounded decisions consistently, nonstop, is this a path to artificial general intelligence, to AGI, to Terminator, to the Matrix level robotics AI? Is this the end of the world? Is that what this could lead to?
I guess that's where we separate from Arman in terms of the the school of thought. Let me go first. I don't think that it's a path to AGI. I have a little bit of how to say marginalized point of view for AGI. It is not possible to reach with LLMs. I believe LLMs are still really dumb models, like really stupid models. like, and it's not a really a way to reach out to an artificial general intelligence by utilizing these next token prediction, or what we call in literature autoregressive models. It's not possible. We have something different. I don't know the answer of that. If I know it, I would probably get the Nobel Prize for that. But I believe it's not the path with the LLMs.
I have to give you credit. The fact that you are skeptical first, as you mentioned in your intro, paradoxically is building more trust with me in your head, or with you in my head, I should say, because you're it's good to be skeptical. I see a new fandangled thing on X, and I'm like, oh, this is the future. It's inevitable, and we get sucked into these hyperbolic narratives really easily. So, Arman, tell us why he's wrong. Tell us why SERV reasoning framework will lead to singularity.
So first, we don't know the definition of AGI, right? Everyone has a different definition, and for me, it's the AI is able to operate like a human being in everything. And obviously, this has multiple aspects of it. Like you need to be able to, I don't know, have a robot that will lift this bottle or fill it. And what I hit back on this is there are deterministic things that should happen, and then there are decisions that should happen. And I think with the SERV reasoning framework, we are on a very, very good path to cover the decisions part. And for everything else that's going to be deterministic, like moving the robot arm to get the bottle, right? Like look at this bottle, like this is where the water is, and now, like let's say, imagine I have a huge stream coming up. I need that bottle full because I don't want to go midstream to fill the bottle. So the robot should know that I have a stream coming up, and that the bottle is it has very little water in it. It should probably fill that up, and it should know where to find the source of the water. Come pick this up, go there, fill it, and bring it back without me telling it anything. Now, this is one example of AGI for me. We could obviously have like hundreds of different examples for medicine, for law, for finance, whatever. It doesn't matter. The examples are all very similar in what I'm going to tell you next. And that is, there's the part of reasoning. Oh, okay, where is the bottle? Where's the water source? How much water does it have in it? Should I fill it because there's a stream coming up? Those are the decisions. And then there's the mechanical execution of it. And for that mechanical execution, yes, you need to know the physical shape of the bottle. You need to know how much pressure the robot arm should have to squeeze the bottle to lift it up, because it also is a little bit heavy, right? There's a difference between lifting up an egg, because you could break the shell, and lifting up this glass bottle. So those things, I think, are tool calls. Everyone would know by now with like Cloudbot or other AI agents. There's the skills and tool calls. Like you basically get like calendar integration, your email, your calendar items, whatever. I see those things as deterministic as those tool calls, or getting the result of a mathematical equation. Now, one thing is to come up with the equation to apply, and the other one is to come up with the result of the equation. LLMs might be great, and next token prediction might be great in the first. It's definitely absolute worst in the second. It cannot do math, but it doesn't need to, because that is something you can deterministically do with a tool call. And that's why I believe we can get to AGI by better reasoning. So what I think is the blocker between us and AGI right now is the sophisticated reasoning layers that we lack today. And that's what we're trying to tackle with the SERV reasoning framework and platforms in the future. And I would very much love to win that Nobel Prize together with you, Dr. Eyup, in like 20 years' time.
Hopefully.
I think people can look back. I'm not exaggerating, maybe a little bit, a tiny bit. In 20 years' time, people might look back to today, to this stream, and say, well, that's actually where we invented AGI. So because that's how Nobel Prizes work. Like you win it for your work 20 years prior. And I think our work is at that scale. And the implications, because I'm using it firsthand, and a lot of people in the world, I cannot give you direct numbers, a lot of people in the world are affected by SERV reasoning framework right now. And the results look very promising. So I'm just looking forward to applying this to many more use cases. And we have so many more projects that we cannot talk about today that will prove that.
Maybe I can add something a little bit more on my previous point of view with LLMs. I don't want to sound like LLMs are like not or useless or something like that. I believe there's a huge ROI of utilizing or leveraging LLMs, and now it's actually agentic AI, by coupling with the tools and memory. I believe in terms of the automation and the software businesses, it's going to be a huge ROI expecting in the upcoming years. And I think that's what really is important. If we just put the discussion of AGI in one side and talk about the critical potentials of LLMs, it's not something that we can minimize. I just want to put there as a side note.
Beautiful. So let's take it back to reality for a second, right? Where we are today, at least. SERV, right? Building this incredible AI founder suite for you to build, launch, and run your entire crypto startup in one place, right? As you look at the available tools that are here on OpenServ and are obviously becoming connected to the platform every single day, because OpenServ can connect to any framework, any chain, really anything, kind of. What do startups look like? What do companies look like when everyone except the founder gets replaced?
So I think like there's a lot of nuances to that. The goal might not be to replace people. The goal might be to supercharge them, because obviously like humans are still way, way, way better at certain tasks. And ingenuity is one of them, and that's what we're trying to model with all these tools. But what we're trying to give founders is practically all of the best practices that we know, that we have garnered over the years in running your startup, building and running your startup, so that we cover for your lack of experience in these fields, and we cover for your needs, for your immediate needs to run this startup at scale. But obviously what's going to happen is, like, you can definitely build a unicorn on this, but at some point, this is human nature, right? That you're going to be like, well, what is the next step? And there, human AI collaboration begins. Then maybe instead of you talking to your marketing manager agent, you're going to have a colleague that will do that for you, who knows a little bit better than you in terms of marketing. So their results will also be better. So the suite of tools that we're trying to build here is giving you, I'm not sure if I'm allowed to talk about all the tools that we're building. We're actually building like more than 10 tools right now.
Let's do it.
Really?
No.
Like, so
don't quote me on that.
We're building more than 10 tools, and it's going to grow in the future, that will help you with all of the tasks that you would normally do as a founder yourself. Look at what's out there on the market, your competitors, how you position yourself, how you talk about yourself, what you bring out as a unique value proposition, and generate promo materials and so on. So there's a huge window of opportunity for us to automate these tasks, and we have gathered a lot of experience while building, launching, and running OpenServ. So we want to share this with the world.
And Dr. Eyup, let me color that differently for you, right? Because I think Arman hit the nail on the head that it is going to supercharge every individual at every company everywhere in some way, shape, or form if they use this technology the right way. Companies like Salesforce, right, who made the news for kind of going back on their decision to have these massive layoffs a few years ago because AI narratives were taking over. I mean, Meta is included in that, and Google. But now they're starting to say we need people to come back in the office. We need to hire again. We need to do less metaverse, less virtual reality, and more teams that know how to enact AI in these systems. But again, for those single founders, for those small teams that want to compete with these larger organizations, can you share some of the things that you've seen or nuances or anything that you're excited about that shows how a small team, a single founder can compete in ways like never before?
Yeah, actually, really good question. Thanks, Ryan. What I believe, in my point of view, is generative AI, agentic AI, or AI overall, is going to be a huge multiplier effect to the team of the people in the companies. What I see here in the big picture is that employees that are doing average or maybe not like a junior level of work will be completely eliminated. However, employees that have a really specific expertise in terms of like software or coding is still needed, are going to be also needed, because these AI products, or like we talked before, the results of, let's say, the code that AI generates cannot be fully trusted. So there has to be a human in the loop component to verify the AI for unforeseeably long feature. I don't know if you have heard about it. There was this term called vibe coding that people people start generating like apps with vibe coding. Oh, so good. We don't need any more software engineers. Now, there are experts popping up on job platforms with the title vibe coding cleaning experts. There's a kind of job right now. So this shows us that AI for the unforeseeably long feature ahead cannot be truly replaced by the experts. It will reduce your team of people maybe from 20 to 10 or 5. And with 5 engineers, you can maybe compete with 200 engineers of big companies. That's what AI levels you off with the big players, so that startups can really compete with. I call it a multiplier effect of AI. But I don't think it will be completely eliminating everyone in the company. There will be still one person to call out when things go really long in the middle of the night.
Yeah.
And that should be a really huge expert.
And here's the thing: there's a phenomenon, a paradox called Jevons paradox. I don't know if you heard about that. It basically states that when a resource becomes cheaper and maybe more efficient to use, we just use more of it and not less. And like, look at electricity, right? Like, I don't know how many lights I have in this house just surrounding me right now. Just because it's affordable and easy to use, I have way many more electric light sources than I really need in my life. But I use that. So I think AI is like that. And the more we use it, the more we will need to use it. And the more we will need to use it, the more we will need humans. So yes, today, Dr. Eyup is right. You can you can rival huge companies with maybe 1/10 of the workforce. But there's going to be a time where everyone will have 1/10 of the workforce and the game will equalize again. And someone needs to break the loop. And that's when you start having more people. Because then again, in order to have twice the gain, you need twice the people. But what I really love about this is we now need the brains in people. Maybe repetitive work, whatever, they get eliminated. But the human ingenuity will never disappear, and it's only going to get better with AI. And those are the tools that we're trying to build. First, to make you successful as a founder, But then obviously the more people, brains, creativity you can put into the system, the way better results we're going to get. So that's where we're headed. In the end, there's going to be a merger. Like, we're using computers today to do most of our work, right? Like, a majority of the workers are digital, at least in the technology industry. AI is like that. It's just going to be like that. We're going to work with AI, and um, not a lot of people lost their jobs because of AI. There were new jobs created. Sorry, because of computers, there were new jobs created, and it's going to be the same. So that's not to be conflated with the one person startups that we're building. It's for the start. It's for a sustainable startup. Previously, you needed a team of 10. Now, for a sustainable startup, you need only you. The tools that we're building will be taking care of the rest, but that doesn't mean that you're going to be the only person forever in that company, because that just doesn't make any sense. That does not fit the economic reality. At some point, you're going to need to expand. You will want to expand, because what if everyone is a solo founder? How do we create that economic difference without changing the parameters of the game? So, like, it's a longer philosophical discussion, but at least we're democratizing running startups. That's how we can call it. Beforehand, you needed a lot of money, huge investments, a large team that you can trust, and now we're practically making it more accessible to everyone.
Nice. So to put a bow on that, and it seems like you're both sort of in agreement that AI is making it possible to start and run something real as a solo founder, but the long-term picture is still teams of humans plus AI, not one person companies forever. Obviously, you want to scale and grow, and humans have this ingenuity. And speaking of that, it was a really great point, Armand, because I saw that two news reports in early January. The first being that roles that encompass the title storyteller were really taking over marketing roles across Fortune 500 companies. People are looking for new narratives. They're looking for human storytelling, because if you ask ChatGPT or Claude to tell you a story, it's not going to be as great as that family member that you have that tells great stories, or one of your friends telling you about a memory in college or elementary school or something, right? We still need human beings to give us that authenticity and ingenuity and body language. But I think more than just the flesh, it's, if you imagine a founder listening to this who wants to start with a one person plus AI setup today, OpenServ is a system they can do that, and a workflow that they
Right.
can make themselves, and you can hand over all this work to AI, and that's just incredible. So before we close out here, I did want to ask one more question, right? Could an AI, if it were to start a company by itself, I'm taking out the one founder, right? If you told it bounded reasoning AI model, you told it to make a profitable business, and I gave you guys some time to think about this. It said, make a profitable business. I'm going to give you Claude Bot. I'll give you all the MCPs, all access to my computer and the internet. Could it theoretically compete with a to almost a monopolistic level in a certain industry or niche at some point eventually?
I think it theoretically can, but how are you going to build that system? That's like, it's asymptotic. It basically, the limit is infinity. Like, you have to spend infinite amount of energy to build that one system that can create companies that can do this. And again, it's not the brightest thing in the world, because it would equalize everything else and there would be no wins, and that company will also, I guess, like, just get destroyed. So there are two sides to that story. I think it's theoretically possible. I don't think it's possible at all, realistically. And even if it were, it would just take like 10 minutes for all of them to crash, because you would create billions of those companies and then there would be no profits, no nothing.
Dr. Ayup, I'm sure you're a naysayer on this point, right?
Yeah, like as a as a scientist or a scientific, side of it's part of the things. If yeah, I don't think it's really quite doable.
So we got a couple more questions in the community section here. This one from Al Peru. As I understand what this braid model does, instead of communicating through natural language with AI models, we are communicating with them in a more efficient and cost-effective way. Arman, you want to clarify that for our friend?
So it's basically that's what it is, in a way more efficient way, that as a result is cost effective. And because LLMs are better at understanding more languages than just English or natural language.
This one from Tama. I don't think we need people to review the AI's output because humans make plenty of mistakes as well. What do you mean? I've never made a mistake. I mean, ask my wife. Yeah, it's a lie. What we actually need is clear accountability. Wow. Okay. Accountability on both sides. So not just bounded reasoning and decision making, but tell me a little bit about accountability, how that works in this relationship.
Dr. Eyup?
Yeah, so that actually falls into the gray area of who is accountable for doing what. It's like, these self-autonomous driving vehicles. They have these deep learning models. They decide how to drive the car, but they crash someone. Who is accountable for that? Is it the person in the car, or is it the model? So I think it's a chicken and egg problem. That area is something that needs to be grounded. Maybe there has to be some clear policies within the department. If you use AI generated code and just plays it like as is, you are accountable for it. If you are a great software engineer and maybe that code is not a perfect way of implementing that algorithm, or there are some loopholes in the code, it's your job to pinpoint that bug before it goes to the production. So there was this story, I think one of the well-known companies, it's called Replit. They used to make these AI-generated apps with no coding. One of the engineers, they put the code in the production. He got it from the generative AI for a database, and it was including a lot of drop table or delete table commands. He didn't realize that it was gonna blow off the entire production database. And now who is responsible for that? I think it's the engineer who didn't catch the bug in the code. Sometimes the line is very clear, sometimes it's not. And I think an expert who is doing a really good job in terms of software engineering comes into play at this point, and he cannot be eliminated.
We will not be eliminated, folks. Don't worry. Speaking of elimination, the last comment here from Samar Pri before we roll out of here. It is in our sector, it's a well-known fact that as of now, every single software building platform like Lovable or any other software only works for very small projects. I'm saying projects because they are not products. When it comes to architecture, it's a mess. How is SERV better than them? If you could go more on that.
So first, we're not writing code. Like SERV reasoning framework or the SERV platform does not build apps for you, and that's the main distinction. We are on the platform side, we're a autonomous multi-agent orchestration platform. Either you bring the agents or you use the agents that are already on the platform and you bring them together. But what we're doing is a multi-agent orchestration. And then with Braid and with the SERV reasoning framework, what we're laying out is the foundations to better decisions. And someone could take this and build the next gen Lovable that has better decisions because it has better reasoning, so therefore it has a better architecture. But I also don't realistically see that being correct, being true. As a software architect, like I use AI coding all the time. I don't necessarily write code, but since 15 years, I'm not really writing that much code on my own anyway. I'm helping my engineers with their decisions by giving them blueprints of how they should code themselves. And it might be sad to say, but there is a point of view where I replaced my engineering teams with AI. I didn't let them go. They are also starting to act like software architects, and they also work with AI, who's doing the heavy lifting of coding. But I think human level reasoning in software architecture will not be replicated for a very long time, because that is true expertise, and it's very, like, no one has codified it before. It just does not exist. Doesn't even exist in books. It's like the combination of all the experiences that you gathered in life. And therefore, you still need to be in the driver's seat with multiple prompts to fix the architecture of those apps. And in the end, yes, Lovable or platforms like that, single prompt generation platforms, are great for very small projects, tiny mocks, not even real projects. But any sort of real project would require way better reasoning. And the thing that we're proposing, at least, is if you adopt this framework, this reasoning framework, you're going to have better reasoning as a result. So you might improve your chances of better outcomes. And that's basically what we're using in our day-to-day jobs as well. Like it's called dog fooding, using your own solutions in solving your own problems. And we are also seeing way better reasoning and adaptation when we're working with AI coding tools, but not necessarily at a level to satisfy an established software engineer. That's just very difficult.
Wow. Okay. I think we've covered enough today. And if we keep Dr. Eyup any longer, he's going to be added to the website at a higher frequency. We might just rebrand SERV to Dr. Eyup SERV. We want to let you go, but friends, we're going to land the plane here. But listen, I will send a transcript out for the community to check out, and the team will distribute it. I want to summarize some of the highlights in plain English, because this was pretty dense for a lot of folks, and I want every person here to walk away with something usable. Number one, the first thing we talked about is that demos lie. Like, the lab is controlled, production is chaos because it's not a controlled environment. There's high stakes. And Dr. Eyup, you had a really good analogy about the bar. You set up a bar for people to order different drinks, different sizes, but the first customer asks about the toilet. I thought that was hilarious and very true about, if I was going to use a new AI tool, I'm not going to make the same prompt as any other customer when I first check it out. Number two, we went over enterprises, what governments, what they actually buy is not smarter AI, but they want to buy predictable AI. And that's what SERV Reasoning Framework is supplying. And every single founder that's building on OpenServ or launching on OpenServ and running on OpenServ will have access to this SERV Reasoning Framework that has this bounded decision making, that enterprise level organizations that work with governments like the United Arab Emirates, like NEOL, they're trying this tool because it works for them. So we want to make reasoning behave like infrastructure and make it super easy for you. So I want to give flowers to Arman. Thank you for grounding this all in the reality of what it takes to ship as an entrepreneur yourself, an incredible inventor. And you're getting your flowers on your Cornell research paper as well. And Dr. Eyup, thank you for bringing so much academic rigor. And I got to make a glossary after this episode of terms so I can keep up to date with you. But that's exactly what this space needs. So
as much as possible. But
so I want to give you guys opportunity to close us out with any predictions or any thoughts based on the conversation. We'll start with you, Arman.
I'm just very happy and proud to have done this work. I think it's life-changing, and it's definitely shaking some ground. And yeah, I'm looking forward to the next couple of months to see a much wider adoption. And also, like, it feels great to be one of those people to drive that adoption myself. It's great.
Dr. Eyup?
Yeah, it was a great pleasure to be part of this work, and I'm really excited about the feature work that we actually put it also in the paper. We have some exciting avenues of research that we really want to explore, and hopefully that will put the self-reasoning and the braid into the next level in terms of the academic community. Yeah, I hope that we will see those results as well. Thank you.
Amazing. And the community, I can tell they loved it. They were engaged today. And if you're listening and you want to plug into what we're doing, here's a simple call to action. Follow us on X at OpenServ AI. That's where we drop research, updates, and the live product rollouts. If you want the SERV reasoning framework paper, go read it, go share it. It's live. It's being peer reviewed by some of the best and brightest in AI today. And so excited about that. And if you're interested in the NEOL work, the high stakes case study, you can sign up and get early exclusive access to that one as soon as it launches. And if you're a founder, OpenServ exists for you to help you build, launch, and run with an AI team. Again, not just shipping a demo and production ready product matters, right? So we want to make sure that you have something that's ready for you to take to market, make yourself some cash. So if you're serious, reach out. And for the community, I love you. Okay, keep sending questions. You're genuinely steering the direction of what we cover next. The quality of the questions is only getting better. And that's it for today. So appreciate everyone who showed up live, everyone replying and replaying later. Thank you so much for your time, and everyone building with us. So we'll post the replay, we'll clip the best moments, and we'll make sure we're back soon with the next session. God bless, take care of yourselves, and as always, be bullish on yourself first. Take care.
Take care. Thank you.
Thank you.